Alright, so we're going to look at the derivatives of inverse hyperbolic functions. Okay, so in the previous video we talked about the derivatives of hyperbolic functions. So which they are just the basic ones, such as the hyperbolic sine, hyperbolic cosine, hyperbolic tan, hyperbolic cotangent, hyperbolic secant, and the hyperbolic cosec as well. All right. So what we focus on now is the derivatives of the inverse hyperbolic functions. Okay. So let's say we are given a function y is equals to uh, hyperbolic sine inverse of x. Okay. So I want to find what the derivative is for that one. So here, instead of me writing or having y is equals to that function, I'll say my x is equals to hyperbolic sine of y. Okay, so what when you reach this stage, you need to differentiate both sides of the both sides of what you have there. So instead of differentiating with respect to x, I'm going to differentiate with respect to y, because in this case I've made my x to be subject of the formula. So instead of me having dy dx or d dx, I'm going to have my d dy. Okay, d dy, d dy of x. Then I'm going to also have my d dy of hyperbolic sine of what? Sine of y. And d dy of x is just going to give us dx dy or x prime. Okay, dx dy, which is going to give us the derivative of hyperbolic sine of y is simply hyperbolic cosine or cosh of y. Okay, so this now gives us to say our dy dx. Remember to say I've just flipped it. That one goes up, the other one goes down. So here I'm going to have what my 1 over hyperbolic cosine of y or cosh y. But is that all that we are talking about here? The answer is no. Okay, the answer is no. When you look at the identities that we indicated earlier, from one of the identities, which is simply the simplest one, or the first one that comes from the equation of the hyperbola, we had our hyperbolic hyperbolic cosine of x, hyperbolic cosine squared of x, but in this case I'll express it in terms of y. I'll say it was minus hyperbolic sine squared of y is equals to 1. So what we do here is that I have my cosine here. Hence, what I have to do is that I just have to make the hyperbolic cosine the subject of the formula. So meaning I'm going to have my hyperbolic cosine squared of y being equals to 1 plus hyperbolic sine squared of y. Okay, what we need is the hyperbolic sine. What we need is the hyperbolic cosine of y, not hyperbolic cosine squared of y. So we need to square both sides. Okay, square both sides of what we have. So that is going to go and that is going to go. We're going to have hyperbolic cosine of y being equals to the square root of 1 plus hyperbolic sine squared of y. All right. So what before I even replace that into the dy dx equation, I would love to simplify it just here and like at this stage. So I have the square root of 1 plus. Okay. So now instead of me having hyperbolic sine squared of y, keep in mind to say at this point we have what our x being equals to hyperbolic sine of y. So if we say x squared, our x squared will be equals to what? Hyperbolic sine squared of what? Sine squared of y. So here I'll just replace with what? With our x squared. So meaning our dy dx is equals to 1 over 1 over 1 over the root of square root of 1 plus x squared, like that. Okay, so this is the standard equation that we are going to be using, or that we are going to be using as we differentiate any inverse hyperbolic function that we are given. And one thing that I would love us to understand is that when you look at the numerator, the numerator which is a 1, and a part of the denominator which is in this case the x squared there. Okay, so if I were to express the x in terms of u, okay, if I say my x is equals to u here, right? So what you're going to have as a standard equation, so that we're able to see it in terms of u, such that you can be anything, we are going to say our dy dx is equals to our u prime, okay, u prime um, divide by root of 1 plus our u squared. So this is the equation that we're going to be using. So this is what you get if at all they ask you in terms of this in this way. But generally it's supposed to be u prime, then down here you have what, your u squared, like that. Okay, so that's all in this video. Thank you very much for watching.